All right, so the last section for this week is going to be a quick review of arc length and also an extension into area of a sector. So a sector is really like a piece of a pie. You're cutting out one section of the pie that's going to cover a certain central angle. All right, so on this first problem here, it says find the length of the arc AB and the area of the shaded region. So when I look at this arc AB, first thing that we have to remember is that for arc length, all right, we're always going to go with a fraction of the circumference. All right, so when I look at arc length, so if I look at AB, all right, and we want the measure of that, we're going to take some part of the full 360 degrees around the circle, all right, and then we're going to times that by the circumference, which is given by 2 pi r. All right, so when I think template, this is really the template that I have for arc length. All right, I'm using a 100-degree central angle. If I have a 100-degree central angle, I'm using 100 out of 360 parts of the circle. All right, the circumference on this one would be 2 pi r. R is 7. All right, so from there, I've got 100 over 360, which I can take that down to 10 over 36, which reduces to a 5 over 18. All right, 2 times 7 is 14, so I have 14 pi. All right, 14 and 18, I can reduce those down. So I've got 5 times a 7, and I took a 2 out, so I've got a 9 in the bottom, times pi. All right, and then 5 times 7 is 35, so I have 35 pi over 9. All right, so if we're working on a calculator, we can take that pi using the pi button, all right, times 35, all right, which gives us a 109.955, and then we're going to divide that by 9, and that gives us approximately 12.22. All right, if we did this. Now, that's arc length, so this would just be units. All right, now our approach for area of the sector is actually almost identical. The only change is instead of taking a fraction of the circumference, we're going to take a fraction of the area. All right, so if I want to find sector AB, so we're going to say area, sector, and I'm going to call it by AB, just the ends of that chord. All right, we're going to take a fraction, all right, of the area. So the fraction is going to be some part of the 360, right, times area, which is pi r squared. All right, so our fraction is still going to be 100 because that's the central angle. R in this one is going to be 7. All right, so now we reduce that down to 5/18 again. All right, so we have 5/18 times 49 pi. All right. And from there, we're going to have some calculator work. So I've got 5 times 49, all right, which is 245. So I have 245 over 18 times pi. Now, that's not a great number. It doesn't reduce on us, though. So we could stop there if we're looking for an exact answer. Right? Or if we want to go to an approximate answer, we can take that. We can take 245 times pi and get a value. All right, and then once we do that, we can divide that by 18, and we'll get 42. So this is approximately 42.76. Now, that's an area, so we're going to have units squared. All right, so that is basically like a quick example of arc length and area of a sector. Keep in mind the structure on both of these is very, very similar. What changes is whether we're taking a fraction of the circumference, like on the first one, or we're taking a fraction of the area, like the second one. Either way, we're taking a fraction of a complete circle. All right, so let's hit one more example. All right, so example 2 says find the arc length of arc AB and the area of the shaded region. So we're going to approach this very similar to the last one. So we'll start with arc length. Let me get a pen instead of a highlighter here. So I have measure of arc AB. We're going to take a fraction of the full circle, which is 360 degrees, and we're going to multiply that by a circumference, all right, which is given by 2 pi r. R here is 9. All right, and then the fraction that we're looking at is 120. So if I reduce, I've got 120 over 360. That's 1/3. 2 times 9 is 18. So we have 1/3 times 18 pi. And 3 goes into 18 6 times, so I end up at a 6 pi. All right, this is a length, so we're just going to have units for our answer. And that would be our arc length. So arc length, we took a fraction of the circumference. Now, if I find the area of that sector, so area sector, and I'm going to call it AB again. All right, on this one, we're still taking a fraction of the 360, and we're still multiplying by a full feature of the circle, but this time the feature is area, which is given by pi r squared. All right, so we're taking 120 degrees out of the total 360. R is 9. All right, so I've got 120 over 360, which is 1/3. 9 squared is 81, so we have an 81 pi in there. 3 goes into 81 27 times, so I end up with 27 pi. And that would be units squared, because we are looking at an area there. So again, both problems we take a fraction of a complete circle. For arc length, we're taking a fraction of the complete circumference. For our area of a sector, we're taking a fraction of the complete area. So those are two examples. Tonight's 5-problem homework set has very similar problems. They're going to focus in on the new topic, which is area of a sector. Because that is the new skill. The old skill of area of an arc length, I chose not to assess in this homework set. Good luck with tonight's homework. If you have any questions, just send me an email. Thanks. Bye.